Okay, this is problem number 5 on section 1, chapter 11. Um, First of all, I need you to read the chapter on the book, from the book. Read that section before attempting these problems. Understand the basis. Okay, so here we have a 4 categories where they have a record of the number of checks whose cents portion end between 0 and 24. Like for example, let's say 34.15. Like you have this amount in the check. This check falls in this category, right? Because this portion is between 0 and 24. So you have 100 checks, and in this table they show you the observed value on each one of these categories. We have 4 categories. Okay, we have 55 on the first category, 21 on the second category, 12 and 12. Okay, so the claim is that the 4 categories are equally likely, which means what you expect is that if you have 100 checks and you have 4 categories, you would expect that each category will have 25 observations, correct? Because 100 divided by 4 is 25. So you need to have 2 lines, one for the observed, and one for the expected. Okay. So once we have this is going to be the L1, and this is going to be the L2. Okay. So let's go to the calculator, and let me go to stat. You go to test all the way to the right, and you scroll down all the way, and you're looking for an option that says goodness of fit. Okay, I forgot to tell you something. You need to set up, of course, you need to set up this table on stat, on edit, and you need to set up this the first category on L1 and the second category on L2. In other words, the observed on the L1 and the expected on the L2. Okay, so after that we go back to stat, we go to test all the way to the right, and then you go down until you find the one that says chi-square GOF, which stands for goodness of fit, right here. That stands for goodness of fit. Okay, that's a 11.2. Okay, so you press enter, and on the observed, make sure it says L1. On the expected, L2. Degrees of freedom. Well, in this case we have 4 categories: 1, 2, 3, 4. 1, 2, 3, 4. So the degrees of freedom in this case is the number of categories, which is 4 minus 1, which is 3. And at this point you might well, we are here. Okay? At this point we might either press calculate or draw, whichever. I mean, you press draw here, you're gonna get this picture. If you press calculate, you're gonna get the same numbers. I mean, the 50.16, and the p-value very close to 0. This number right here, I mean 7.38, 6287 times 10 to the negative 11. That is a very, very, very low number. It's something like, I mean, in scientific notation, it'll be something like that, which is very, very small. Okay, close to 0. Okay, so that's how we get the test statistic. I mean, the 50.160 is the test statistic. Okay, the critical value. Well, for the critical value, we need to go and pull out the table. The table is obtained by clicking on this link, and this is what you will obtain here. We're using a 10% significance level. So let me go to the next page, and here that's the significance level, and we have degrees of freedom is 3. Okay, so basically this is our critical value. Okay, 6.251. Okay, you might find this on my MATLAB. I posted all these tables, my MATLAB. Let me go back and okay, so that's the number you get here. Okay, so the null hypothesis in this type of test is that the proportions are equally likely. Well, in this case, you say the proportions are equally likely because that's what the claim is, right? The proportions are equally likely. So that is the assumed situation. And the alternative hypothesis is that at least one of the proportions is not equal to the claim value. Okay, or at least one of the proportions is very, very different. Okay. So basically, the critical value, let me go back and write the critical value, which is 6.251 is right here. That is the critical value. Okay, and our test statistic is 50.160, which is way, 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 way too far over here. I mean, is very, very far away from this fail to reject the null hypothesis. I mean, any value after 6.251, you have to reject the null hypothesis. Okay, this is not the p-value method. This is a different method, which is known as the critical value method. But either you do this problem by using the p-value method, you will get the same conclusion. Just in this case, they want you to do this problem using the critical value method. That's why we gotta get this critical value to determine what value is gonna make my what is the value that I need to know to reject the null hypothesis. Okay, so anything below 6.251, you fail to reject. Anything after that, you have to reject the null hypothesis. In this case, you see how the answer here is reject the null hypothesis, and the claim is actually let me see here. The claim is that the four categories are equally likely. So the claim is here. The claim is here. So the claim is on the let me read this table right here. Okay, the claim is on the null hypothesis. That means it contains equality. Okay, and you reject the null hypothesis, which is our case, right? So this is the way you write it. There is sufficient evidence to warrant rejection of the claim that, and then you just all you gotta do is paste this part, the claim that the four categories are equally likely, right? So that's how you enter these blanks. Okay, so that's how you do this part.